go on to the next round, then their idea, which is the most amazing idea about helping starving people in third world countries, will actually have a massive impact on the world. That's just fantastic. You could die then and be completely happy because you've made this awesome impact. Not that you'd be happy to die, but you know what I mean? You'd be peaking early, I'm thinking. But no, you'd be on a good trajectory. You're happy as you are because already people are using it. Well done, guys. That's fantastic. Well, that's very good. Yes. You should turn the camera around. Onto you. Onto Amy. Yeah. And to you. You should turn around to you. So, yeah. Oh, you didn't shave. Okay. Well done. That is just fantastic. I hope you all go on to do cool things like that, using your powers for good rather than for evil. There were 2 announcements. One is change your default notification settings for pages. Woohoo! Just do that by changing your settings over here. And you can change.
By default.
Yes, it's a default.
No, so you set the default for everyone.
Yeah. What?
I think when it got implemented, they set the default for everyone.
To be subscribed to everything,
yeah.
Which I hate completely, but it's better than subscribe to nothing. And in the pipeline is you can sort of partially subscribe. That's right. So if you wanted to turn it off, you'd go to that settings page. Also, we've added some stuff at the top. You can probably see there's a blog feed. I hope people have been seeing that. It's really fun. I've been having fun going there. If you click on that, you just see the latest blogs anyone's made in the course.
I can't believe you saw that blog post I made last night. I made it at 3 a.m.
I see blogs all the time. I'm always going there. You should be doing that. You click on them, you observe them, make comments on them, give people praise. It's fantastic. So there's hundreds of blogs sitting there. So, for example, no one's made a blog for 49 minutes. Jeremy did. Where are you, Jeremy? Wave. He's probably 49 minutes away. He's been running ever since. He's still blogging.
What's the ordering of it?
The ordering is, I think, last edit date. No, I have no idea. It's Rupert ordering, it's called. It's a special ordering. Yeah, Rupert really wants recent changes, so he's actually implemented a vast amount of stuff so we get recent changes. It's really cool. So anyway, it's really nice. So please do look at everyone else's blogs and make comments on them. If you don't want people to see your blog, you can ACL it down so people can't see it, but it's really good to get people commenting on your stuff. That's great evidence. The other thing I want to draw your attention to is the gallery. Before, the tutors would have to manually edit things to stick it in the gallery. No one had the time to go through the rigmarole to stick something in, and so things weren't getting added. But now, to add something to the gallery, you just got to tag the page. So look at this blog entry by this crazy guy. This is a blog entry for me. I made a blog entry about how a sewing machine, being amazed at how a sewing machine works. Here's how I got it to list on that page. No, let's look at another blog entry. That's already on the page. Okay, so this page, I love this page so much. I think this page should be in the course gallery. Let's put this page in the course. This is very slow. Let's put this in the course gallery. So all I do is I give it some tags. I'm going to tag it. I think to put in the course gallery, I have to go COMP2911. Yeah, that's the one. And I also have to tag it gallery. There we are. Now that I've tagged the page, it's in the course gallery. If I go to the course gallery, you'll see the Romer acceptance tests. They just popped in. Pretty soon you'll be able to like and unlike, vote up and down, so the things on this page will be in a sensible order. And we'll age them and things like that. Okay. Anyone that does anything good, I'm asking the tutors to tag it and put up good solutions to assignments here. So I'm hoping this will get populated quite quickly with some of the good things we've seen. That's all the admin stuff I wanted to say. Now, I did want to do one other thing, which is I've started commenting on, oh, thank you, Daniel, that was cool. I've started commenting on some pages, on some blog pages. Let me go back to my, where am I? Because I'm looking at everyone's blogs now, because there's a blog feed, and I'm really enjoying doing that. And when I look at the blog pages, I've started making comments to help, like to make suggestions, and then I think how good it would be if everyone could see all the comments rather than just the people I'm talking to, because I keep saying the same thing over and over again. And let me say what it is that I keep saying. Every time I read a blog entry, I think normally, awesome, this person made a blog entry. I'm really proud of them. They've clearly watched the video. I'm really proud of them. They're a smart person. I'm really proud of them. But gee, I hate this blog entry. Because the blog entry doesn't live up to how awesome and smart and intelligent and proud of them I am. It looks like the blog entry, in some cases, was written by my daughter at high school still. It's not a bad thing because you've never probably gone and done blogging 201 or something at uni and reached a postgraduate level of blogging. So let me tell you now, and you'll instantly transform from high school level blogging to university level blogging. And it's this: you don't say anything general unless you back it up. I don't care if you don't say anything general at all, but don't say something general and not back it up. Don't say, I love this, I hate this. It's just like, I don't even see that, I filter it out. Don't say, this is really good, this is really bad, this is a good design, this is a bad design. Don't say, I've done lots of stuff and I had lots of good ideas. This is just rubbish, can you see that? I've done good stuff and I've got good ideas means nothing. I'm not saying rubbish in a bad way. It's better than me. I haven't managed to blog for a week. You're already better than me. But what you've got to say is when you've got that thought in your head and you're writing those words, you don't have to think any harder and you don't have to do any more typing. Just type something slightly different. Don't say, I had lots of ideas about the project. Say, what do I want you to say? Yeah, just say one if you don't want to type. If you only want to type for 10 seconds, say, I had this idea about the project and 4 more. We'll ignore the 4 more, but it's nice that you've got to. But say specific things. If you think, I hate this, don't say I hate this. What should you say?
Why?
I hate this because. Don't come up with some general theory of the whole universe without giving some examples. We just want concrete things. So I find that over and over, when I read someone's post, I get excited, but then I always make a comment at the bottom saying, but could you be more specific?
Okay. What you liked about the post you commented on me last
Well, let's just have a look. Did I comment on your post?
Yes, you did.
Oh, you had 2 good lines at the bottom.
Yeah, I just want to know which ones were they?
The last 2 lines.
I should learn more about this.
No, I should learn more about this. Oh, yes, because the this wasn't a this. It was a concrete thing. Let's have a look. Where is your post, Alexis? Is it here?
No, it's from one to... what's that one? That's the one that was made.
We're going to Richard's blog. We're going to find something about Richard's blog. I'm going to make a comment. I'm going to edit my blog. Blah, 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 blah. I'm going to tag it. Blog. Suggestions. That's what I call it. There we go. Blog suggestions. Now it's a blog suggestion. What that means is you see all the tags appear at the bottom of the page. You click on blog suggestions. You'll see all the blogs I've made suggestions on.
Oh, that's it.
That's the one. Let's have a look at Alexis's one. Okay, a whole lot of stuff here that shows that you've read and thought about the lecture as it's happening. So all of that's okay, but the best thing about his blog happens at the bottom. Instead of just describing something he's learned, he flags some consequence of it. He doesn't just say, I saw the lecture, it had some interesting things in it. I know what he found interesting. This is interesting. That's really cool. Here, he's made a comment. He's not only just been a descriptive blog, he's had a thought. He's thinking, oh, I should look at this more. This is interesting. Yes, it's very interesting. He's right. Can I look at some other blogs? Now, I'll do Andrew's one. Andrew, it's okay, because I'm completely cool. All right, everything's cool. But I don't think Richard's the best person to give advice on speeches. No offense, just my opinion. He's too sporadic. Okay. So the first 10 minutes I was trying not to source out of boredom. This is a cool blog. Okay, he's writing what he's thinking. There's nothing wrong. You criticize me as much as you want. Except, I don't want, I love Richard or I hate Richard, or Richard's great or Richard sucks. All of those are equally meaningless to me as a university academic. What do I like to see? Yeah. So then reflection is, why am I bored? Or, so what did I say? I gave some specific suggestions. Andrew, it's completely cool. I really like your blog. There's no problem with it at all. I'm not cross with you. I love you. I think it's fantastic. But here's how it could be better. First of all, question. Do you think you need to be good at giving a speech to think about what makes a good speech? So is it fair enough to say, I don't think he's going to have much to say about giving a speech because he can't give a speech? I don't know. It's an interesting question. You could think about it and write something about it in your blog. Is it possible to like music and not be a good player, but like listening to music? Maybe, maybe not. I don't know. You should think about it.
There are people that I know that are great music critics who are not very good at.
Yeah. Whenever I go to education lectures from brilliant educationalists, they give crap lectures. But their insights about lecturing are good. But I don't want to, that's what I think about it, but you might think something else, which is absolutely fine. You just got to say what you think. You only had time there to write a few words, but just make sure those words are about reasoned opinions. Don't take a position on something. A position's not so interesting, but the reasons behind a position, they're interesting. So saying something like, too sporadic, that's like leaning towards what I wanted to see. Say what you mean by that, but also see the logic. I don't think it's interesting to think about speeches because Richard's not giving good at speeches. Just check all the logic. Is the lecture the same as a speech? Is Richard crap at giving lectures? Does that mean he's crap at giving speeches? What's the difference between lectures and speeches? These are all thoughts. You don't have to have them all, but you have to have some. You have to have some thinking. Do you need to think? Do you need to compose like Beethoven before you think? Your blog would be much better if you wrote down specific thoughts rather than general. And this is what I keep saying. Be specific. It sounds like I'm criticising you. Is it cool that I'm not criticising you? I'm completely happy. I'm a very happy man. Everyone says the same thing. Let's find some more. So, Stanley likes it. Oh, well, you're sucking up to me, Stanley. Where are you? Why did you like it? You didn't put a reason. You just said you liked it. You're taking a position. When you click on the like, you need to click on the like and... That's right. Now I think about it. Open learning takes a position on everything. We suck. Thank you, Stanley. You said something else good. You said that awesome comment that's made it to the top of the thing, haven't you? Yeah. Yeah. Very good.
Oh, did anyone see that? Did anyone actually see that video I posted?
No, I haven't seen it.
Ages ago. It was this.
Put it in the gallery.
Yeah.
Let's keep going. Sorry, Alexis. I'm rushing on, not because I don't want to hear what you have to say, because I want to start. Let's pick someone else. Is everyone thinking, oh, don't pick me. Let me just pick someone randomly. I'm sure, not Andrew again. I nearly picked him again. This week, Stephen said something. He's doing something. Oh, someone made good comments. That's fine. That's fine. Blah, 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 blah. Bad design example. Okay. These are nice observations. Oh, no, that's no use. It's no use. Where's another one? Is this one here? Randall. Let's look at yours. Blah, blah, blah. Da-da-da. It's a great blog. Oh, good. Here's why I like it. Has lots of specific information in it. If you say specific things, it's good. Let's have a look at what he said specifically. Okay, it's an informational blog. He's just talking about what he saw. He's explaining it. He's not inserting himself so much. There's not so much reflection, but it's good. I expect you'll find it helpful when you want to revise. If you do, then... Oh, okay, I actually say it. I just say it in a more nicer way. So it's a great blog because it's got lots of good information in it. Where's Randall? Wave at me, Randall, so I can make eye contact with you. There. It's a great blog post because it's got lots of information, and the information you've chosen to put in is the important information. So it's really good. It shows that you really understand what you're thinking about and writing. That's perfect. And what would make it even better is if you say, even if there's just a sentence at the end, yes?
Sorry, to get your blog onto this page, does it just need to be set to public?
Yeah, it'll only come up here if it's public. Or it'll come up here for you and for me. These might be private blogs I'm revealing to everyone. I'm sorry if I'm doing that. Yeah. So you can't see some of these? So the ones you can't see would be private blogs. So I'm sorry I'm splattering your private blog. Maybe if you've got a private blog, say somewhere it's a private blog so I know it's private. That might help me. Yeah. Oh, yours isn't there in the blog feed?
It was broken last night. Theo changed something which broke things.
So your blog's missing. Go and edit it and see if that slicks it in there. If it doesn't, then tag us on the blog and we'll work out how to put it in there. Oh, you can manually put it in. It's just a matter of getting the right tag at the bottom. Look at the ones that are in there and see what tags they've got. You tag yours the same way and it'll appear in that feed automatically. Okay, is that cool? So does everyone understand what I'm saying? Keep blogging like crazy. I love it. But in your blogs, don't just give information. Give opinion, take a position, But don't just take a position. Justify your position. Yes? Cool. Got it. Everyone's doing good. Okay, now let's get on with the lecture. So we're moving forward in time to week 3.0. As you know, I expect, next week's our quiet week, the Dark Ages. Does everyone know we're moving forward in time? Each week of the course is a different period of history. We've just passed through the Renaissance. That was 2.3. We're entering now. I mean, the Dark Ages is a crap name for a period of time. It means everything. It's all of history. Well, it started before, it went after. So I'm not going to use the word Dark Ages, the phrase. I'm going to use different words like Spanish Inquisition, witch hunts, that sort of stuff. Hate them. Joan of Arc. That crazy religious period when everything went dark. The last break we had over Easter, that was the Crusades, you might have noticed. We've just slowly moved through history. After the break, we're going to be up to the Enlightenment. We'll be Beethoven, which is very exciting for me. So now we're after the break, even though it's before the break, because I'm giving you a lecture in advance. Here are two poems. They're both copyright Disney, so we shouldn't look at them. Okay, let's begin. Last lecture, before the break, before I was in isolation, how nice it is to see you guys again afterwards, I spoke a lot about how to give a speech and how to design a speech. Is this a course about speeches? No. Do we care about speeches? No. Why was I talking about designing speeches? Anyone want to have a guess? Design principles. Yes. It turns out designing a speech, designing a chair, designing a car, designing a movie, designing an ad campaign, designing a legal campaign, designing a book, designing a program, designing a logo, designing a meal, designing a life. All these things involve design. They all involve a whole lot of stuff in common. Sure, they've all got different bits as well, but the bits they've got in common are much bigger than the bits that are different. And they are understanding the problem and having a reasonable and creative and thoughtful process which produces reasonable answers to the problem rather than solving the wrong problem. And the answers tend to be qualitative in that you can't necessarily say this one's better than that, this one's better than that. But there are certainly bad answers and there are good answers. And design is really the art of constructing or selecting the better ones over the worst ones, subject to all the constraints you've got. So when you write a speech, the guy that writes the speech or the woman that's going to give the speech has a constraint and a problem. They've got an audience, a location, a period in time, a duration. They've got a room they're giving it in. They've got all these constraints on them. And then they've got all these objectives that they want to solve. I want the people to leave thinking this or knowing this or so on. It's possible to design bad speeches and be a bad speech designer, and it's possible to design brilliant speeches. So we talked about some brilliant speeches, and I conjectured about what might make a speech good and bad.
And brilliant speeches you don't know are brilliant when you give them.
Some you don't know are brilliant when you give them. Well, yes.
Most always we do.
Yes. Well, Gettysburg. I don't know if he knew how good that was
I know that
when he gave that.
the one given by what's his name during World War II.
To fight them on the beaches.
That was just one of many speeches. And
Yeah, he didn't know that one's going to make it. In fact, he was actually talking about some beach midges that were biting his children. It was only later he realised it could equally apply to the war. So that was a fortunate speech. That's right. So a brilliant speech. I don't want you to give brilliant speeches, but I want you to think about the process of design and the process that people go through when they design stuff. All right, now we're up to the Enlightenment. And the cool thing about the Enlightenment is it's this period in time when everyone's very optimistic and people are using rationality and reason to try and solve problems. People are no longer taking positions on things. People are hunting for reasons and asking questions. People no longer say the Earth is at the center of the universe and burn you at the stake if you say, why do you think that? Or I don't think that. Now they're asking questions. And when someone says heavier things fall faster than lighter things, they ask questions. Why do you think that? They do experiments. They try it out. It's a time of questioning, of doubting everything, and of boldness, of excitement, of realizing once you start questioning and doubting, you can find answers and you're not left with more uncertainty but less. It was this wonderful time and it really swept across at least Western Europe and eventually the rest of the world. like a wildfire, changing all sorts of amazing things. And this is, I guess, what we were doing together, if you were with me or whoever you were with when you did it, in 1927. For me, that's really an Enlightenment course. It's about science and questioning for the first time. Not just saying things like, and I've seen it, this is a good program or this is a bad program. What does that mean? We start to quantify it. This is exponential, this is quadratic. It's fantastic. I love it. Voltaire, the poster boy of the Enlightenment. I love him completely. He said many awesome quotes. Here's one. Liberty of thought is the life of the soul. He's saying you should be free to think. You shouldn't be constrained. You should be allowed to question. You should be able to challenge. You should be able to think whatever you want, and that will lead to good things. So he's pretty anti-censorship. He had that other awesome quote, of course, that everyone knows.
Except the fact that he was pro-censorship.
He was pro-censorship, but he probably...
It's funny. No.
Well, there was a lot of weird things happening in France with them supporting stuff theoretically that then their actual infrastructure wasn't doing, like supporting the American Revolution, for example, at the same time as having their crazy king and all that sort of stuff. It's possible to be inconsistent. I've heard that. I've never experienced it myself. He said the thing like, I may not believe what you say, but I'll fight to the death for your right to say it, or something like that. That's pretty cool, I reckon. All right, so the story so far, design, solving problems. Let's start thinking about solving problems. Let's think about solving computing problems. Up until now, we've been spending all our time solving problems of this form. How do we represent a situation? How do we model it in data? What's the appropriate structure to use, the data structures to use, and the relationships between them? And we've been solving structural design problems. But now I want to move to solving algorithmic design problems. Like someone gives you a task to do, and you don't know how to carry it out. How do we solve that problem? For example, you want to find the tallest person in the world and call them up on your mobile phone. That's a hard problem. How could you do it? One way is you could get your phone out and just start typing random numbers. Hello, are you the tallest person in the world? How tall are you? You could do it that way. So the idea is a random approach or a brute force approach, which just goes through the search space sequentially, will work, yeah, but it's really inefficient. So we've got a way of solving the problem that's a correct way of solving the problem, but not all correct ways are equal, just like not all chairs are equal, and we want to design better ways than that. So what I want to talk about now, and for the next couple of weeks, is this. Not how to solve specific problems, so we will use specific problems as examples, but instead to look at the process of how we solve problems. So when you see a new problem that you've never seen before, you can start to think, oh, this sort of approach is good, or oh, this sort of approach is good. The trying everything approach, what's that called? Brute force. What's good about it? What's bad about it? Thank you. It works, it takes ages. Here's some other problems. I've got a bicycle. I love riding my bicycle. Often I ride places I've never been before. I like going on holidays riding my bicycle. Sometimes I'm camping and I'm riding my bicycle. Often happens, I'm miles from anywhere and I'm buggered and I just want to rest. But I know I'm a long way from the campground still, wherever I'm going. And I'm cycling along and there's a fork in the road and I could go both ways. And they're both about the same length. I know that. But on a bike, when you're buggered, you don't care about the length of the ride, do you? Your legs just keep going. The length's irrelevant. What is all you care about, subject to there being no cars around, is the gradient. Which one involves climbing up more hills? Which one involves climbing up less hills? Now, I remember once I was cycling near Wiseman's Ferry, and I came to a fork in the road, and I knew both paths, winding and meandering, eventually led to my destination. And at the fork, one went up and one went down. Which one would you take? Who's going to take an upper? Who's going to take a downer? They're both plausible strategy. What's your thinking behind the up one?
If they both arrive at the same place, then you want to have the hard part over first.
If they both arrive at the same place, you want the hard part over first. These answers and the way you vote are probably saying a lot about your personality. Who's going another upper? Actually, there is a reason why you want that. No, don't say it then. Just say your opinion. Don't say it as truth. What's your opinion? Why would you pick upper?
I would pick upper because when you're doing an endurance race, it's most of the energy that you have that you can use up quickly.
Yes.
Happens at the beginning.
Sure.
You want to do hard effort first because the easy effort later.
Yes. You want to do hard effort first.
You can't get that energy store that you can use for the hard effort
Yes.
at the end of the race.
That's why I'm doing recurrences last in this lecture and we're chatting at the beginning. Okay. Who's doing downers? Who goes down first? Why? It's there now. Bird in the hand, man.
Because, if you're going down, you'll build up momentum and you'll have some energy that will take you up if there is enough.
Say that, did everyone hear that? That was a good one. I hadn't even thought of that. If you go down, it'll help you with the next up. Mind you, if you go up, it'll help you with the next down.
But you've already won that.
No, yeah, but it'll help you with an up. Yeah, you're starting with one up counting against you. Yeah, that's good thinking.
I would just depending on how much it goes down.
Yes.
How much it goes.
Yes. Certainly, if it was intolerably up, you'd think, I don't care which is the best way. I can't bring myself to do this right now. Yeah.
Yeah, and if you're going, you will end up at the same level. I
Yes.
guess. So if you're going a lot up, you will go a lot down.
Yes.
If you're going a little bit down.
Yes. Yes, that's a good point. Every inch you climb, you get rewarded with by a drop later on. And every inch you go down, you have to pay for later on with a climb up. Assume your beginning and end heights are fixed. They don't have to be equal, but let's make them equal. You've got two paths. One might go like this. One might go like this. Obviously, this is better because it's got less upping in it. This guy goes up and down a lot. You're doing the upping more than once. Here you only cover that vertical distance twice. Yeah, here you're covering lots of vertical distance multiple times. But you can see that at the point you make the choice, and here's the key thing, you have no information about the rest of the path. You only have local information, the information of what's right in front of you. So how do you choose? Now, if you could work out the whole strategy by making a choice with the information right in front of you now, and you'd be guaranteed to get the best strategy, what sort of strategy could you use to solve the problem? We've seen brute force strategies. Brute force strategies, you cycle both of them and work out which is the best, and then you cycle that. But there's another sort of strategy you can do if it turns out that writing the beginning bit tells you all you need to know to solve the whole problem. Then you can use a strategy called, yes, there's a name for strategies like this. Greedy, thank you. Greedy strategies are pretty cool. With a greedy strategy, you make a series of decisions, and at each time, you have enough information in front of you when you're making the decision to make the right decision. If you were doing a greedy sorting algorithm, here's what it would look like. Here's an example of one, a really cool one. I pick each number up, I look at the number, I know exactly where to put it. Now, maybe that happens if you're sorting the numbers 1 to 10 and you've got 10 spots to put them in and you know you've got 10 things, then you can do that. But what if you're sorting 10 random numbers? You can't do that because the decision you make now could be right or wrong depending on what happens later on, which numbers you pick up next. Maybe you think, oh, 6 will go in 6, and then it turns out every other number is a 1. So 6 had to go in 10. You can't know it till the end though. So at the time you're making that one choice, where will I put the 6, you don't have enough information to know the answer. Sometimes problems are structured such that you have enough information locally at the time you make the choice to make the right choice. Whenever that happens, you can solve the problem with a greedy algorithm. What do we like about greedy algorithms?
They let you ignore information.
Yes, they let you ignore information.
They're simple.
They're simple. They're very simple. Normally, they help you make a... Well, you're always going to make the best decision. The question is how much work you've got to do to make it.
Fast.
They're fast. Who said that? Yes, Michael, Alexis. They're as fast as can be. Fast is fantastic. They just... Well, not necessarily, but the strategy is fast. It's a fast strategy. It's thinking, I'm going to solve this problem in a series of decisions, and each decision I'm only going to have to make once, and I'm never going to have to go back and undo some of my decisions. We'll talk about what the not necessarily meant in a sec. We'll get to that in a few points. We've seen the bike hill climb. Can you do a greedy bike hill climb? No, you can't. What did I always do? I always went up. I was the same personality as you. I was thinking, I'm going to have to pay for this later if I go down, whereas if I pay for it now, maybe I'll just get downhills later. I don't know if it worked or not, but so the crazy thing, of course, is you can see if the path looks like this is one path, here's the other path, and you have a series of choices. I realized one day I'm just pathologically climbing to the top of the hill before I go down it by following that going up. But nonetheless, it's what I did. It's what I did. All right, the coin change problem. Some people know the answer to this, so please just don't say anything. You got a bag of coins. No, you're a shopkeeper. I'm buying something at your shop. I give you a $10 note. You have to give me some change. It turns out you want to give me change with the least number of coins you can for some reason. It's faster to do that or something. You've got to give me $7.30 in change. How do you determine, what's an algorithm for determining the minimum number of coins you have to give me? You've got to do it all in coins. Hey, no, what did I say? Shush, 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 shush. You've got to be shush. Only people with lots of hair can answer this question. That's the rule. That's the rule. You've got long hair, so you can answer. Have a shot. No, concretely. Don't be general. $7, what did I say? $7.30. What are you going to give me first? No, it's only coins.
Oh, coins, sorry. $2 coin.
You're going to give me a $2 coin, and then you're going to give me another $2 coin, and then you're going to give me another $2 coin, and then you're going to give me a $1 coin. 20 and a 10. Yeah, that's right. So at each point, you're making a choice, just picking the largest coin left that's available. It's a greedy strategy. You don't have to think ahead at all. Does that strategy always work?
With our system of currency, it does.
Yes, it does. With our system of currency, it does. In fact, currency systems are normally constructed in such a way that such a system will always work. Can everyone, in fact, get out a pen and paper and quietly, without calling it out, write down a currency system for which it won't work? And because you know I'm me, and imagine this is a blog post, I don't want some vague, airy-fairy claim that it won't work. What do I want? An example. Yes? No, don't say anything. I want you to write down a series of coins. So our system is $2, $1, 50, 20, 10, and 5. Come up with some other denominations such that, it's a J. Such a J strategy won't work. A greedy strategy won't work. You've got like 60 seconds. Go. Quick, 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 quick. It sounds like an exam question. Of course, it can't be an exam question now I've said that. Yes.
Are we restricted in any way with how many
No.
coins?
No. Just pick up a denomination system that a greedy strategy won't work. She's got an unbounded number of coins. She's a very wealthy shop. Oh yeah, no, they've got bounds. That's a different problem. So suppose you've got...
Literally, like for example, if you withdraw 130, you can't do the 50-50 because there's no 30. An ATM only gives 50 to 20.
So that sounds good.
Yeah, that's what I was thinking.
So write it down. Yeah. Okay, 10, 9, you got it. All right, shh. I've forgotten your name. Boris, shoot it out.
I think that any currency that you make such that the number above it is not a multiple of it, it screws up. So let's say if you have, 12 cents.
Give me, I need a concrete example, 12 cents.
If you have 12 cents, everything's the same, $2, $1.50, except you've also got 12 cents in there.
The 12-cent coin, I love that.
Let's say you want to make 30 cents.
Yes.
Guys, you get 12, 20, and then 12. They already make 32 cents, which doesn't work.
No, but the strategy would go, if I wanted to make 30 cents, I find, what's the biggest one?
Which is 12, and then it'll go,
No, the biggest one that fits in.
oh, that fits in.
Yeah. So if you think of the current change strategy, if I asked you for $1.75, you'd give me $1, then you'd give me a 50, then you'd give me a 20, but you wouldn't try and give me a 10, you'd give me a 5. Yeah.
I have one.
Yes.
You have a currency system that has 3 and 7 cent coins only.
3 and 7, that's from Estonia. I was in Estonia, it's a lovely place.
You try to make 9 cents out of it.
You try and make 9 cents, you're in trouble.
You'll pick the 7 cent coin.
You pick the 7 first, and you won't get the 3.
For your example,
Yeah, oh yep, we've got some more examples. Hang on, I just want to move across because I had a good one from Andrew too. Andrew's one was drawn from everyday life.
So like, I've noticed that the ATMs,
An ATM machine.
people don't like breaking 50s, right? Like, if you're buying a $2 item and you give them a 50, they stare at you as if you're something. But I wanted 20s, and I found that since it only gave 50s and 20s, if I get $80 or even $130, it'll give me 150 and 420. But that would definitely not work. So the example is 130.
Yes.
So 130 is possible. You need 4 20s and a 50, but you can't use a greedy strategy to calculate.
Okay, that's a good answer. Can I say though, the problem with, I have a slight problem with both these answers, and the problem is just that I didn't state the question very well. With both of them, there are some certain amounts you can't make. Like, yeah. So for example, something can cost 3, but it could never cost 4. That's a bit crazy. So I want something that is, you can get we're only interested in multiples of the smallest coin, and let's suppose the smallest coin is 1 or 10 or something.
But then, in our currency system, you can't make something of 4 or 3 cents.
Yes, no, that's right. So everything's multiples of 5.
But everything in my currency, you can make multiples of 3 in my currency. You just need multiples.
No. What I'm saying is, yeah, I'm not saying it right, am I? You've got to get everything up from there. Just make the smallest thing 1. That would make me happy. Or 10. So in our system, divide everything by 5. I want everything to be reachable.
I feel like if you make the smallest coin 1, a greedy algorithm will almost always work.
Yeah.
Okay. Shh. This is a good theory, but you've done 1927, so you're not going to rest with that theory. You're now going to try and prove it. And it turns out, this is the thing about greedies. They're fast, unless you pick a stupid one. I mean, you can always pick a stupid greedy one, but if you pick a good one, it's fast, if a good one exists. You can't always do it. Only problems where local information is enough to solve the problem. And whenever you come up with a greedy solution, and it's always really good, and you really want it to be the right one, what do you always have to do with a greedy? Always. We need a proof. So never hand in a greedy solution to something without a proof, because you'll be fooling yourself, because you want a greedy one to work. You love it. So yeah, can you come up with a proof? Oh, well, what if we come up with a counterexample?
we both have counterexamples.
You have all right, who are we next? Was Carl? I thought I heard Carla calling out. What was your one?
I said if you have coins 75, 50, and 5,
75, 50, and 5.
try and make 100.
You try and make 100.
Yeah.
Okay, that's not going to work. So everything's got to be a multiple of 5 in this system, but you can get all multiples of 5.
There's other easier ones. So I have 1, 3, and 4, and she has 1, 4, and 5.
1, 3, and 4. What's a counterexample for that?
6.
6. You can't get it quickly because you want 2 3s or a 4 and 2 1s. Yeah, greedy stuff's up. Okay, good. And what was your one? 1, 4, 5. And what's your counterexample? 8. It's all non-intuitive, isn't it? Can you see this? Because I felt exactly the same as you when I first saw this. And this is why it was lovely when you raised that conjecture, because it's great to have conjectures and we always conjecture. But the difference between a UNSW graduate and a random person who's learned how to program Java in 24 hours or something like that is when we think, oh, this greedy algorithm will always solve it and it's really fast, we then go quietly into a room for about a day doing proofs and writing bloody tests like crazy, whereas they just release it. Okay, that's the thing.
Someone finds a test that breaks you
Well,
and your computer to go and run in a
That's right.
loop.
Okay, here we are. Maximizing happiness, maximizing wealth. Here's a choice you've got to make when you're constructing your own life. Shall I go to the lecture today or shall I go to the beach? And I went to the beach about a week or 2 ago. Rupert took me down because we saw Junji. Was it Junji we saw? Where are you? Yes. And who else? Was it Wendy? Did we see you as well? Who did we see you with? Sherry, that's right. We saw you guys there and you said you'd just been to the beach. So Rupert and I thought, we're having a meeting, let's do it at the beach. We walked to the beach, it was fantastic. You guys, I don't know what you're doing here. You should be at the beach. There's ice cream and everything there, it's fantastic. So you have this choice ahead of you. Will I go to the lecture? Will I go to the beach? Which is what your obvious objective is, to maximize happiness over your whole life and have the best life you possibly can. However, you might think that if you maximize happiness in the short term, it might not necessarily, at every stage, it might not lead to the best outcome. Certainly that's what your parents think. Yeah, stop playing that video game. You should be doing something you don't want to do now because later on it'll make you happier. And of course we all know, if you just listen to your parents your whole life, you'll never be happy. At some point you've got to reap the rewards for all these hard decisions you're making. You don't want to be Mr. Hill Climber Richard. Yeah. But similarly, I reckon if you just bummed around and never did any homework and never turned up and never worked hard and never did anything that wasn't fun, you're actually going to end up with a life that's less fun than someone does a bit of that. But, you know, you do too much of that. I know people who've done both. You do too much of that, you're never happy. They're always hill climbing. So it's a hard choice. I don't know what the answer is, but I do know, I think, that a greedy strategy is no good. It's one of these situations where early things depend on later things, and you can't just make all these decisions in isolation. Yes, you can. That's called Groundhog Day. Yes. Okay. How to read words. Have you noticed, as you read words, and I noticed this with my daughter when she was learning to read, you can't just make decisions about how to pronounce the word as you read it left to right, because later bits can stuff up earlier bits. So there are all these exception rules and things. It's actually quite hard to teach a young child how to read if you're just a left to right rule-following person.
Why we don't just write the IPA?
What's the IPA? Internet of Phonetic Alphabet. I learned Indonesian once. I loved it. It was pretty damn phonetic. I could read it left to right pretty well. So those people that are...
I read it when I sing
Yeah.
music.
Yes. Okay. Here we are. Here we go. And oh, well, I had another exercise, but maybe I'll leave it as a challenge for you. Shh. How can we teach how to solve problems? Because, of course, we're now looking at how to solve problems. Greedy method is one strategy. I've got a problem when I design the course, which is how should the course be structured so that at the end of the course you guys know how to solve problems? That was a problem I had. How would you solve that problem? You've seen how I'm trying to solve it. Would you do it differently? I'd be very interested to know. It's actually quite a hard problem. What's that?
By example.
By example, maybe. Yeah. The apprenticeship system is all right, but it's hard to generalize. So example is good. It stops it being airy-fairy and arty-farty. But it's got to be reflective at some point, and you've got to generalize from the examples. If it's just example. So you've got to have this conflict between moving between concrete, compelling, and then learning how to abstract, reflect, and generalize. Otherwise, you'd graduate a whole lot of people who know how to solve 57 million different examples, but as soon as they see a new example of the sort they haven't seen before, they're stuffed. But if they only know the high-level stuff, they're doomed when they go in the workforce because everyone knows all these standard examples that they can just pull out of the hat, and these guys have to work out everything from first principles. It's hard. Solving examples is compelling and beautiful, so I think as much of that as possible is good. It really inspires you when you see how other people have done the problem. How can we solve problems? Okay, I want to talk just a bit about solving problems in general. Then we'll have a little break. I'm going to finish the break. We're going to have a break with a puzzle. So during the break, you might want to work on the puzzle. You might already know the answer because it's such an awesome puzzle. If you do, please don't tell anyone else. So the two examples I want to talk about how to solve problems are like this. I just want you to think in general about the problem of solving problems. I read when I was young in a really good book by a guy called James Fix about a puzzle in one college exam of some people that had to know something about physics, some sort of engineers, I guess. And the question was something like, how would you compute the height of a building, say an office building, if all you had was, and I don't even know how to pronounce it, an aeroid barometer, some sort of atmospheric barometer. Aeroid, yeah. Shh, don't call that the answer. How would you do it? Now, the professor had an answer he wanted. How would you do it?
I'd drop it off the side of the building.
That was one. Drop it off the side. Count. Time it. Know the velocity of acceleration is 12 meters per second squared. You work it out. That's a pretty good answer. He wasn't looking for that answer, but that's a damn good answer. Another good answer. Yes. Say that again. Oh, exchange, yes. One student said, go to the guy that owns the building and say, if you tell me how tall your building is, I will give you this perfectly good aeroid barometer. These are valid ways of solving the problem. They're not the first way that would come to your head. Your idea of exchanging it for a tape measure or something is pretty cool too. Yes? Count the number of floors. Yeah, just estimate it. Yeah. Hold the barometer against the side if you know the height of it and mark it up. Yeah. Count. Look at the length of the shadow of the barometer. Look at the length of the shadow of the building. Oh, that is good.
The obvious way?
Which is?
Use the pressure difference between the ground and the surface.
Yeah. That's what he wanted. Okay, but these other guys had other ways. My favorite one though is a guy that tied it to a piece of string and lowered it off the edge of the building and then measured the length of the string afterwards when he pulled it back up. He doesn't have any string. That's right. He's not sticking to the constraints in the question. Maybe.
Otherwise, you just hang the string.
Yeah, that's right. You're right. You don't even need the problem. So, the reason I'm talking about all these things is I'm not suggesting this is always how we solve problems, but it's got to be in there. Sometimes that's the right thing to do. I call that unasking the question. So whenever someone gives me a question, first of all, I try and unask it. Do I really need to answer this question? Can I avoid the question in some way? Is there some crazy way of solving it other than the obvious one suggested by the way the problem's worded by the person giving it to me? This, I think, is a critical first step, because if you miss it now, you'll never go back and do this. The second thing I like to do is to change the question. Like, do we really need the exact height of the building? Is within a meter good enough? I can just count the number of floors. Or could I calculate the height of another building? Or are you finding the height of this building because you want to do something else with it later on, and maybe we can just jump straight to that thing and not work out the height of the building? So the idea of unasking the question is, don't always, as your first step trying to solve the problem you're given, first check out if you really do need to solve it, because the fastest way of solving a problem is to not solve it. Okay, so if you can't think of a lateral solution, a crazy one, you can't change the question, you can't unask the question, and you can't throw the question away, then you think, has someone already solved this question? Now I notice, and the classic example is the spot system. I'm sure I've mentioned it before. Every time I run a course and it has spots, the person that I employ to look after the spots says, oh, this is a great idea. I did this course and we had spots, I hated them. I'm going to rewrite it. I've now got like something 90 versions of spots. And I've even stopped asking them, I just sob quietly. And I say, could you write spots for me? And they go, yeah. And they go away and they come back a week later and say, you know, I've got this great idea. And I'm going, yes. I'm going to rewrite it in D. Is it going to be much better?
It's already been done in D.
It's been done in D. I'm going to write it in E.
4 times.
Yeah. So never do that. Reuse if you possibly can. Don't solve the problem if someone else has already solved the problem.
Can we have an archive of all the releases of spots that have ever been made?
We should. No, there have been some fantastic ones, but the problem is they haven't added together in wonderfulness. They've all just replaced each other.
Can we just have it just as an archive of this
Yes.
is the reason why not to do it?
Yes. Possibly. Let me think about how to do that without releasing student information. That might be tricky. I guess what I'm leading up to now is this notion of what we're going to be doing these next couple of weeks is not the same sort of algos you did in 1927. We're going to be looking for design patterns for algos. So in other words, we're not going to be solving specific problems, well, we will, but instead we're going to be trying to take that step back and abstract and generalize so you get general skills. And one design pattern is a greedy pattern. One's a brute force pattern. They're often called design methodologies. Standing on the shoulders of giants is what Newton said. This whole reuse thing is, you definitely should be standing on the shoulders of giants. Don't try and do stuff yourself if it's already been done. Is exhaustive search viable? That's the next question I ask. Because if exhaustive search is viable, I just do an exhaustive search. These are the steps I go through when I try and solve a problem, right? Notice I haven't yet tried to solve the problem until now. All the other steps up until now I've been trying to avoid solving it. Now I sit down to try and solve it, I think, will the dumbest, simplest, easiest thing I can think of work? And if it will, that's what I do. Even if it's not beautiful and I can think of an awesome n log n algorithm or something, if I'm only doing it to 10 or 20 cases, who the hell cares? And I'll probably get it wrong. So I try and do brute force if I possibly can. If I can't do brute force, here are my next 2 steps. This is going to be the flow chart that we follow over and over again over the next 4 weeks. I see if I can break the problem into parts. And if I do, I can. And then I repeat for each of the parts. If I can't break it into parts and nothing else comes to mind, then I do try it and see. Try it and see is I just stick some stuff in. I start doing random examples. I come up with a crazy idea and I test it out. Maybe it works, maybe it doesn't, I don't care. I don't mind if my try it and sees fail. I'm just doing them to get more information so I start to understand the problem better. What I'm trying to avoid when I'm solving a problem is sitting still, spinning my wheel and starting to get stressed and not know what to do next. I need to be constantly moving and progressing and keeping my emotions happy and my energy positive. That puts me in the right frame of mind for solving problems. Stress doesn't do it. You get writer's block or problem solver's block, you're stuffed because all the time you're worrying you can't solve this problem. So if your boss gives you something and you can't do it, then do a crap version that does solve it. Solve an easier version of it. Think of a random solution that might work. Just do something, constantly be working on it and moving forward, iterating and iterating. Okay, now I'm going to give you a puzzle and we're going to have a break. And then after the break, we're going to look at 2 design strategies. The puzzle is this, and some of you might have heard it. It's another thing with an aeroid barometer. You had great fun dropping the aeroid barometer off and counting how long it took till it broke. And it smashed it completely and utterly. And you thought that's quite surprising because it was a strong aeroid barometer, but it just dropping it off this 50-story building destroyed it utterly. And then naturally being a computer scientist, you thought you'd generalize. And you thought, I wonder if there's a general principle or property here that I can observe. I wonder how high I need to drop it from in order to smash it to bits. I reckon if I just dropped it off 1 or 2 stories, it wouldn't break. You look in your bag that you borrowed from the uni, and you've still got 2 aeroid barometers left. You've got an N-story building. You can drop it out of any of the windows at any height. You need to find the maximum height you can drop it without smashing it to bits. That's the question. How high can you drop it without smashing it to bits? I don't mind if you smash the 2 of them to bits, though, in order to answer that question. What's the minimum number of drops? Because you're lazy, you hate going up and down the stairs. What's the minimum number of drops you're going to have to do in order to answer that question with an accuracy of, work out what floor? You've got 10 minutes or less to think about it, and then we'll resume the lecture. So go. Does anyone want to clarify that question?
Yeah.
Yes, question?
Doesn't dropping it the first time already damage it, reducing the durability of it? When you
No. Aeroid barometers have this interesting property that they either completely destroy or are absolutely untouched.
Okay.
I don't understand why. They're quite amazing. Yes? Yes, that's right. So, because I'm a uni professor and I'm setting this assignment next year and I can't afford to keep paying for these barometers, so I'm damn well going to give the students the tallest, hardest problem I can and keep the barometers safe. But I like the way you're thinking. Yes.